Hi, so today we're supposed to solve the problem for the whiteboarding for the class, and one of the HackerRank problems that we choose to solve it. So I ended up choosing the pre-order traversal problem. So for the search of the binary tree, so how the problem goes, it says that complete the pre-order function in the editor below, which has one parameter, a pointer to the root of a binary tree. It must print the values in the tree's pre-order traversal as a single line space separated values. So our test code, the input format is our test code passes the root node of a binary tree to the pre-order function. So these are the constraints. So it cannot be less than one nodes, and the tree can have up to 500 values. And as you can see, the sample input is 1 2 5 3 4 6 1 2, and this is the output we get 1 2 5 3 4 6. And the reason you might be asking is that, well, how come it doesn't print 6? How come it doesn't print 1 2 5 3 6 and 4? Well, that's because what pre-ordered traversal is in a binary tree is that it starts with the root node, right? And then it visits all its left children, and then it visits all its right children. And the one thing about binary search trees is that the values of the left subtree is always going to be less than the values of the right subtree. So we that helps that why this helps us, because we're going to use recursion for this problem, because recursion is basically, if you think about it, it's like a tree. So if we're gonna be working with tree, using recursion is better than iteration, because it'll be quicker, and then we have to write less code. Because how recursion is gonna work how it's gonna work is that I'm gonna have a base case. So the pre-order traversal is we print the root, we print the we visit the left subtree, and then we visit the right subtree. So base case, we can set it as if the root is null, then we return immediately, like we don't have to do anything. And then if it's not null, then we must visit, we print the value of that root node, and then we visit the left subtree, and then we're going to visit the right subtree, and then we're going to print the value each time, because when we're going to have one printing statement, and that's going to print the value of the root each time, and that's going to happen every time we visit a node. So what I mean by that is going to go root, left, and right. So this is the order we're gonna print, but first of all we have to work with the base case. So base case is if root is null, we just return immediately. If let me have space, right, we return immediately, we don't return any value. This is going to help us why we want to return immediately. Let's say we're visiting a node, and node has no left subchildren and no right subchildren. So in that case, we want to return immediately. And if we're going to we want to return immediately, since we're using recursion, it's going to backtrack to the previous call, and then it's going to continue from here. All right, so root is null. So if it is not null, then we're going to print the value of the root. Make sure not to use ln, because one of the requirement is to print the value in the same line, separated, space separated. So if we were to put ln there, it's going to print in each new line, even though if your code is correct and everything, it is still going to give you errors. I'm just gonna create some space because it says space separated. And once we print that value, we have to recursively call the function for the left subtree, and then we're going to call the recursively call right subtree, and then we're going to do root.left and do root.right, because we have a printing statement, because each time we're going to visit a node, and if the root is not empty, we're going to print that. And the way we're going to do it is first root, then left subtree, then right subtree. Pre-order root dot left, right, and we can comment that recursively call left subtree. We're also going to have a right subtree. It says recursively call the right subtree, right? And I believe our code is done because the rest of the code, the node class is given to us by the HackerRank, and then this is also given to us by Hack, so we don't have to get the input data because it's already there. So now the only thing left is to test it. So remember, basically we have a sample input this. So what it's going to do, our code is going to see root is not null, is going to print, is going to see left subtree, there is no child, so it's going to return immediately to the previous call. Right subtree 2, but we're only visiting the left subtree first, so it's going to go down 5, and then it's going to print 2, it's also root, and then it's going down to the 5, that's also the root, but it has left subchildren and right subchildren, so it's going to print that, and then it's going to visit the left, this root is going to print that, and then it's going to visit the left, it's return immediately, so there's no children, it's going to visit the right, and then it's going to print that since there is no left, and then it's going to backtrack to 3, backtrack to 5, and then it's going to see the 3 has already been visited, it's going to visit the right subtree, and there's 6 we haven't visited, is going to print it. So let me just run the code. We don't even have to test against the custom input because it's been given to us by the HackerRank. We just have to run the code and hope it passes the test cases. So there you go. As you can see, this is the input 1 2 5 3 6 4, 1 2 5 3 6 3 4 6, because remember we're gonna print the 4, right? And then we're gonna print later 6 because we're gonna backtrack to 3 before 5, so that's why we have 4 here, and then the last one is 6, right, like that. So now let me submit. Go accepted. I was also gonna let me go over the example here in my OneNote that I created this like a subtree. It's not really looking good, but I just wanted to go over like how it works, the code. So what I pretty much have is that I'm checking if the root is null or not. So root is not null, is going to visit 1, right, is going to print that, and then is going to visit the left subtree, that's the root, right, 2, and then is going to visit 4, the left subtree again, and then it has no children, right, it's just going to print the value. It's going to it's going to backtrack it to 4, and this one has no right children, is going to return immediately. So I'm gonna use the cross to make sure. So backtracks, so then it backtracks to 2. We have already visited 4, so we're not going to visit again. We're here at 2, now it's going to visit the right subchildren, right, and the right subchildren the right subtree, it doesn't have any left subtree because this becomes our root once we visited it, so return immediately. And then this becomes, if visit the right subtree, there is no children there, so it returns immediately. So now we have already visited the 5, this is our root, it's going to print that, and then we're going to go backtrack to 2, it's not going to print that because this has already been printed, has already been visited. Now it's going to backtrack to 1 again, it's not going to print 1 because it already been printed, it has already been visited. Now it's going to go to his right subchildren because it already visited the left subchildren once, so now it's going to go to the right subtree, and then right subtree is going to visit the left, there is nothing there, it's going to return, and then it's going to visit the right subtree, there is nothing there, it's going to return immediately. So this becomes our root, so that's the last value to print is 3, last value to print is 3. So the output we get is 1 2 4 5 3. Okay, so that's the question that I solve for my HackerRank for this assignment, and that's it. Thank you.